Our 7th lecture video on momentum and collisions will cover the topic of inelastic collisions. If you remember from the previous video, an elastic collision is one where the objects that are colliding bounce off each other and return to their original shape. There is no deformation. In an inelastic collision, two objects collide and couple together. This means that both objects have the same final velocity. An example of an inelastic collision would be two railroad cars colliding. They couple together on the track and move with the same velocity after the collision. Let's take a look at a problem involving an inelastic collision. A rail car of mass 5.75 times 10 to the 5th kilograms moving at 2.50 meters per second to the east collides and couples with a rail car of mass 4.00 times 10 to the 4th kilograms moving at 0.750 meters per second to the west. What is the final velocity after collision? Just like the elastic collision example, we first want to draw a picture so we can visualize what is colliding and what the initial velocities should be. First, let's define positive or east to be to the right and negative or west to be to the left. We have the first rail car with a mass of 5.75 times 10 to the 5th kilograms moving to the right at 2.50 meters per second. The second rail car has a mass of 4.00 times 10 to the 4th kilograms and it is moving to the left at 0.750 meters per second. Like I mentioned before, drawing a picture will make it easier to figure out which velocities should be positive and which should be negative. To keep everything organized, let's write down all of the data we were given, including the correct signs based on direction. M1, or the mass of the first car, is 5.75 times 10 to the 5th kilograms. V1, or the velocity of the first car, is 2.50 meters per second. And this is positive because it is initially moving east or to the right. M2, with the mass of the second car, is 4.00 times 10 to the 4th kilograms. The velocity of the second car is negative 0.750 meters per second. It is negative because it is originally traveling to the west or left. We are trying to find the velocity of the two-car system after collision, V prime. The basic equation for inelastic collisions looks slightly different than for elastic collisions. The reason it looks different is because after collision, both objects are moving with the same velocity. The basic equation is m1 times v1 plus m2 times v2 equals the sum of m1 plus m2 times v prime, the velocity after collision. We need to rearrange this equation to solve for v prime. The best way to do that is to divide both sides by the sum m1 plus m2. This gives us a working equation of v prime equals m1 times v1 plus m2 times v2 divided by m1 plus m2. Now that we have the working equation, the last step is substitution. V prime is equal to 5.75 times 10 to the 5th kilograms times 2.50 meters per second plus 4.00 times 10 to the 4th kilograms times negative 0.750 meters per second, all divided by the sum of 5.75 times 10 to the 5th kilograms plus 4.00 times 10 to the 4th kilograms. When you calculate this, you should get an answer for V prime of 2.29 meters per second. Since our answer is positive, it means the coupled rail cars are moving to the east or to the right in our picture. This concludes our discussion of inelastic collisions and of the momentum and collisions chapter.